This is a geometry video portfolio over section 7.4, special right triangles, which can be found in your geometry textbooks. The most confusing part about this section was having to identify the relationships between the sides and angles in a 45-45-90 or 30-60-90 triangle, also known as special right triangles. Common trouble spots include identifying angle and side relationships in these triangles and applying these relationships to find side lengths within the triangle. We will go more in depth on these topics throughout the video. Hello? There's a bomb situation? I'm on my way. There it is! It's a clue. Define the coordinates for the next clue. Answer the following geometry problem. Let's do this. Find the value of x. Refer to the diagram in the bottom right of the screen if help is needed. Using the properties of a 30-60-90 triangle, we know that the hypotenuse is twice the length of the side opposite the 30-degree angle. By using triangle sum, we can find the 30-degree angle. 16 feet divided by 2 gives us 8 feet. The side opposite the 60-degree angle is square root 3 times the side opposite the 30-degree angle. So we can multiply 8 and square root 3 to get our answer, 8 the square root 3 feet. I've got the new coordinates. Let's go! Oh, there's a door. There it is! Ow! Ow! God! Oh. It's the next clue. To find the coordinates to your next clue, answer the following geometry problem. Let's do this. Find the value of x. Refer to the diagram at the bottom right of the screen if help is needed. By using the properties of a 45-45-90 triangle, we know that the hypotenuse is square root 2 times the length of the two legs. By using triangle sum, we can find that the last angle has a measure of 45 degrees. To find the two legs, we divide the hypotenuse by square root 2. We divide 23 square root 2 by square root 2, where both of these square root 2's cancel each other out. We can then find our answer, 23 meters, which is the value of x. There it is. The next clue. What's this? It's a decoy. No! Let's go. There it is. To get the keys to the house, answer this geometry problem. Here we go again. Solve the special right triangle. Refer to the diagrams at the bottom right of the screen if assistance is needed.
Since both of the legs of this triangle are congruent, we know that the two angles other than the right angle are also congruent. So now we know that this is a 45, 45, 90 triangle. This means that the measure of angle Z is 45 degrees and the measure of angle X is also 45 degrees. Through our properties of a 45, 45, 90 triangle, we know that the hypotenuse is square root 2 times the legs of the triangle. 12 times square root 2 gives us 12 square root 2. Now we know that y equals 12 square root 2 inches, and we have solved this triangle.
Done. Got the key. Open! What happened? Let's try this again. Oh, there it is. Wrong answer choice. Done! Where did that come from? That makes sense. I gotta find this ball quick. What was that? Whoa! What is that? What? To stop the bomb, solve the following geometry problem. I've gotta hurry.
Solve the special right triangle. Use the diagrams at the bottom right of the screen if help is needed. Using triangle sum, we can find out that the measure of angle Z is 30 degrees. This gives us a 30, 60, 90 triangle. Using the properties of a 30, 60, 90 triangle, we know that the side opposite the 60 degree angle is square root 3 times the side opposite the 30 degree angle. To find the side opposite the 30 degree angle, we divide 9 by square root 3. Since we cannot have a radical on the bottom of a fraction, we rationalize the denominator. This is done by multiplying 9 divided by square root 3 by square root 3 over square root 3. This gives us 3 square root 3 when fully simplified, which will give you the value of x. The hypotenuse of a 30, 60, 90 triangle is 2 times the side opposite 30 degrees. When we multiply 3 square root 3 by 2, we end up with 6 square root 3, which is the length of y. We have now solved this triangle.
I've got it. To stop the bomb, hit the button. What button? It worked. Oh, that was a close one.